Let's spend this section exploring logical volume management within CentOS. Now, this is a means of aggregating storage from disparate resources, disparate types, or even same types such as SATA, SCSI, otherwise into aggregate forms such as volume sets. And with that, you're able to provide a unified logical storage block to be addressed by a file system and used by your user community, while hiding, of course, or abstracting the underlying components that constitute the particular presented volume. So it's an important tool to allow us to aggregate storage and use it in a liberal fashion. So let's modify our notes file and take a look at the new storage configuration that we've brought up. We've just rebooted the system. Yet again, the uptime should reflect it's only been up a few minutes. So let's label this section Logical Volume Management, or LVM. And discuss its many features. Perhaps its primary feature is the ability to aggregate. So to aggregate storage. And it supports disparate, as well as, of course, similar storage repositories. So, for example, you could pool together or aggregate disparate storage systems such as SATA, SCSI, iSCSI, IDE, and so on, fiber channel. And wherever your storage happens to exist, you can bring it together on this technology. Now, certainly there are going to be I/O gains and losses associated with various technologies, so it behooves you to use technologies consistently, but the idea that you can aggregate in a reliable fashion is a useful function. Additionally, it allows us to manipulate these volume sets, so manipulate aggregated storage, which we often refer to as simply volume sets. And by manipulation, for example, we mean the ability to, let's say, extend, reduce volume sets, add, remove members, storage members, etc. So it provides us with an enterprise-capable volume management solution. Now, it isn't GFS, which is included with CentOS, which allows us to set up a global file system and benefit from high availability features. However, insofar as being able to simply aggregate and use content across a variety of storage means, or store content and represent the content, use the content across a variety of storage means, LVM is a tool to use. You'll find that during the default CentOS installation, it proposes an LVM setup and does so by default. So df-h, for example, reveals the logical volumes that are managed by LVM, where the same volume group, for our example, and various logical volume names associated with various mount points and overlaid with certain file systems. So it is the proposed means of managing your storage by default, whether or not you're using high availability techniques such as RAID, GFS, perhaps a combination of the two, and other technologies, perhaps fiber channel, etc. Firewire, you name it. That's another one another bus type that we should possibly include, since Firewire is a means with which to reference storage as well as USB, preferably 2 or 3 for realized gain. So on and on and on. So volume sets, you can create stripe sets, you can conjoin LVM with RAID technologies, so perhaps underlying RAID subsystems that are managed by LVM. Insofar as the kernel is concerned, so long as there's a driver to drive the RAID provider card or cards, then LVM can overlay to offer another layer of management. So in many respects, you can use LVM perhaps to even replace some enterprise solutions, such as traditional Veritas Volume Manager for enterprise solutions. Now, with that said, let's take a look at the storage hierarchy. So, LVM storage hierarchy. There is a hierarchy in which we represent the objects that make up an LVM. And at its most basic, we have what is called a volume group. A volume group is an aggregate of a number of physical volumes. So aggregate of one or more physical volumes. A physical volume is simply an LVM flagged, so LVM flagged partition which may or may not be an entire disk. So you can use, for example, fractions of disks and flag them LVM and aggregate them into volume groups. So at its core is this notion, it's this abstract layer of a volume group. And when we look at the default setup, for example, df-h, we see the same volume group represented twice. VG underscore, the short name of the host. When you execute host name, for example, it shows you the long name. And if you do host name, let's do help, the S option shows the short name. So the volume group is represented by the short host name. The name, the default naming or nomenclature that's used by the installation program uses a prefix of VG underscore and the short name followed by the attached volumes, one or more. So i.e., as an example, the location is dev mapper. That's where we reference the volume to a mount point. But the key is the name, which has a prefix of VG underscore, a short name, followed by its attached volume. So the volume group is this core component of LVM, and again, it aggregates one or more physical volumes, which are basically LVM flagged partitions. So basically, whenever you assign a partition from any of your free storage blocks, whether it's the entire storage block or a fraction, so long as you flag it LVM, that particular volume becomes a candidate to be assigned to one or more volume groups. Now, the volume group, as we've mentioned, simply aggregates the various physical volumes, which implies that there is a layer called a physical volume. So physical volumes, one or more. And for example, they include devices like what we already have, such as dev SDB1, for example. Let's take a quick look. And we have dev SDB1, this is EXT4, so let's say dev SDA2, which is a partition on dev, let's SU in and take a quick look. Dev SDA2 comes to mind. So fdisk list dev SDA, and we see that dev SDA2 is a physical volume that's of type LVM, which uses the remainder of the dev SDA disk. So i.e. dev SDA2, which is of type LVM, which is type 8E, as opposed to type 83 for a standard Linux flagged partition. So when you create physical volumes for later aggregation into volume groups, flag them as type 8E or Linux LVM. Whether or not you use them immediately is besides the point. Just think ahead when provisioning systems as to how the storage could be used, perhaps as an LVM associated device. So physical volumes are simply partitions flagged with type 8E or Linux LVM as its type. Then you allocate a set number of blocks. So you start off at a block and you indicate the size, let's say plus 10 gigs, plus 20 gigs, or maybe plus 500 gigs, plus a terabyte, whatever storage you happen to have available. So volume groups contain one or more physical volumes. Now from the volume group, we export what is called a logical volume. So logical volume, one or more, so logical volumes, if plural. Logical volumes are basically exported components or storage of volume groups up to the full capacity of the volume group. So for example, this system has configured one volume group. It's called VG underscore LinuxCBT CentOS. Within this volume group, there are two volumes, logical volumes that we see when we execute df. There's another one that's associated with swap. these two are merely abstractions or fractions exported of the volume group. So the volume group has a certain amount of storage available or configured associated with it that then is exported or sliced or spliced into manageable units that we assign for different purposes, such as /home, / or maybe even swap. So from a volume group, we can export or splice or slice one or more logical volumes over which we overlay file systems. So that's the next layer, file systems. And these are overlaid on logical volumes. So just to quickly recap, at its core, we define one or more physical volumes, and we assign one or more physical volumes into a volume group. We then decide what to do with that storage. Let's say your physical volume is a single partition that's, let's say, 20 gigabytes, and is now associated with a volume group which is of size 20 gigabytes. Of those 20 gigabytes, we can export one or more logical volumes over which we overlay file systems that then get mounted in user space for your users to take advantage of, which is currently what we have with this particular volume group, VG_LinuxCBT CentOS. It has exported that we can readily see logical volumes 0 and 1 for two different purposes, one for home and the other for root, and yet another one for swap. So that's sort of the lay of the land as we see it currently. Now, insofar as creating logical volumes, explore 6 steps to set up LVM. Whether you're using graphical tools or not, there are basically 6 steps in setting up an LVM managed volume. First and foremost, you need to apportion partitions that are of type LVM. So create LVM partitions via your favorite partition manager. So let's say parted, fdisk, or otherwise. So that's the first step. You need one or more. So let's just indicate that it may be a single partition. You can always extend it at another point. So we need an LVM capable partition. That's the first step. Once we have an LVM capable partition, we add another label to that partition to indicate to LVM that it is ready, that partition, for LVM management. So that step is called creating a physical LVM volume. So create physical LVM volume. And we do so with the PV series of commands, PV create. PV create or PV commands allow us to manage physical volumes. Physical volumes are partitions that are flagged of type LVM. So creates LVM aware storage physical volume from LVM flagged partition. So step 2 is we define our various physical volumes. Once we have our various physical volumes, one or more, the next step in the process is to create a volume group. So create volume group. And the volume group can be named anything and used for any purpose. Another set of commands are associated with this level of abstraction, and they begin with VG. So we use VG create. And it's rather intuitive. So PV create to create a physical volume, VG create to create a volume group. So VG create allows us to create the volume group with a name and associate one or more physical volumes. So for example, we would do VG create. The name of the volume, let's say we call it vol group temp, followed by one or more devices, let's say dev SD. Now we've been working with dev SDB recently, so perhaps we create a partition named dev SDB3, for example, and perhaps subsequent partitions such as dev SDC, dev SDD, etc. So this allocates one partition, one physical volume into the volume group. Now that we have this volume group that's available with X amount of storage, the next step is to create a logical volume. Now we're at the 4th step of 6, create logical volume And again, GUI tools take care of this for you, but you should understand the steps. Now, for this layer of abstraction, we have a set of tools that begin with LV, such as LV create. So to create a logical volume, it's rather straightforward as well. We simply indicate LV create, but a number of options exist, such as the ability to specify the size out of the entire volume group that should be associated with this particular logical volume. So let's say the space is 20 gigabytes in length, and we intend to use 10 gigabytes. So we'll use the length option and indicate that 10 gigabytes are to be used from vol group temp. And this basically creates 10 gigabytes of usable space over which we can overlay one or more file systems that are of interest to us, such as EXT4, 3, Riser, XFS, etc. So, create logical volume, and this generates dev entry for FS for the file system. Now, once the logical volume is intact, now again, never mind if you initially create the logical volume with an incorrect amount of storage. Let's say your storage needs change. You can always extend. There are a series of tools available to extend. In fact, extension is usually easier than reduction. So you can always stretch your volume out at a later point with minimal impact to your user community. So once the logical volume is in place, the next step for us is to overlay our favorite file system. So overlay or create FS on the logical volume. Now, the logical volume that we've created in this step did not include the name option. So by default, LVM will generate a name for us. We can always name it using the N option. So for example, you just tack on simply the N option, and let's say you call it log vol temp 01, for example, or 00 to index things at 0. So you can always name it, no problems there. You can always rename it. So overlay, create your file system on top of the logical volume. And this just entails, of course, referencing make2fs with the EXT4 option. And if we search our document, we'll see that we recently made an EXT4 volume when we looked at laying out partitions. So let's just take our make2fs command from that particular area. Let's do another search. That's at the top of the document. So, and there's the make2fs type ext4 and the dev tree location that's published by LVM. And then we're well on our way to managing the storage with LVM. So let's overwrite that. And this will be the new dev entry, which LVM echoes immediately. So for example, if we take a look at the df dump, you'll see dev mapper, the name of the volume group, followed by the name of the logical volume. So it'll be a similar format, dev mapper volume group hyphen. So that's going to be dev mapper. And on some systems, it's slightly different. It's specified in a slightly different way, such as dev mapper, the volume group name, followed by another directory entry. Either way, it's rather easy to follow. So for us, this would be vol group temp, for example, hyphen, let's say log vol temp 00, for example. So this would overlay the ext4 file system. So that's a fifth step. And then finally, the sixth step, of course, is to mount and update etcfs tab. So update etcfs tab and mount, or mount and update, either or. So you can separate out into 2 steps to make it 7 overall. So really, 6 easy steps to setting up LVM. GUI tools take care of this for you, but if you understand the basic components that are associated with LVM, it's rather straightforward. LVM components largely consist of volume groups. Volume groups consist of 1 or more partitions that are flagged LVM and have been enabled as a physical volume using the pv create command. So just to give you an IE here, it would be pv create, and let's say the name of the volume, such as SDB3, for example, under dev. So that would associate dev SDB3, which has been flagged LVM as a physical volume that can then be assigned to a volume group. And then once we have 1 or more volume groups defined, we abstract the volume groups into a set amount of storage known as a logical volume. So we take a fraction or the entire thing, and then we overlay a file system. If things change later on, then we simply extend the logical volume out of the volume group space, and then resize the file system. Usually for extensions, not a problem. It can be done online with the appropriate E2FS tools. So with that said, it's time for us to make an LVM volume. So create LVM managed volume. Now we have added storage, we've rebooted the system, and we've added storage. So let's use fdisk with the list option to show the various disks where you'll see we now have, in addition to devs SDA and B, SDD, which is yet to be defined, and SDC. So these are two areas where we can overlay information, perhaps using parted. So we need partitions, and as we've mentioned, we need LVM partitions via parted fdisk. So the first step for us will be parted dev, let's say SDC, to manage that disk. And then within, we create a partition, which we've already done using make part, and we set the type to LVM. So let's parted dev SDC. Let's print the current configuration. It is currently unrecognized. There is no label. Now, if you recall, we've already labeled a disk as type, one of our disks as type MS-DOS. That's dev SDB. So to do it, it's rather straightforward. So we can go ahead and relabel this. So make label. And if you don't specify a type, it prompts you for what type. MS-DOS, for example. So now let's print. So here's our storage. 20 gigs roughly, VMware Virtual Disk. It's ready to be partitioned. So to make a partition, we make part, and then we specify the type of partition. Again, it's in our notes. If we just do a search on make part, you'll see make part, if it's primary, its number, or its offset, that is, and the size of the partition. So let's make part primary, and again, it's where the partition starts and where it ends in terms of cylinders or size. So supposing out of the 20 gigs we'd like to use 10 GB, then just specify 10 GB. Now let's print. Again, these changes take effect basically immediately. In rare circumstances when using parted, will you find that it doesn't take effect immediately. So let's copy all of our commands thus far. So in addition to running parted, we did make label MS-DOS. So make label MS-DOS to label the disk of a certain type. Need not be labeled MS-DOS. You have other types. Just do a help on make label. And then we make part. So make part, and this is going to be primary, the offset cylinder-wise, and its size, 10 gigabytes. So that gives us 10 gigabytes of storage, minus 1 megabyte usually. Once that's in place, we have a partition with which we can add to our volume group configuration. So let's quit parted. Of course, it warns that we will possibly need to update fstab, and that's certainly true. Let's fdisk list dev SDC, where we see SDC1 ready to go. But notice one problem. It's of type 83, not type 80. Now, by default, as we've mentioned, Linux file system or Linux partition manipulation tools such as fdisk and parted will flag a disk as type 83, which is type Linux. So the next step really is to set the type. This is an important step. Otherwise, we will not be able to associate this storage block with LVM. So to set the type, we actually use the set option. There's actually a set option that's in parted that's rather straightforward to use. So for example, let's go back into parted. For dev SDC, for example, and do a help, you'll see that set is one of the options. So you specify set, the number of the partition, and its flag. Now, how do you know the number? Just print the partition table, and you'll see the partitions, including their numbers. So if we set, in this case, partition number 1 to type LVM, and its state is on. Now let's print it again. Now it is type LVM. So set 1 LVM. Let's quit. And let's go back and print this again just to be sure that it's what we expect. Now it's been updated to type 80 Linux LVM, so that's more like it. So set one LVM on. And this sets the partition to type 8E, or simply LVM. Very important, otherwise we cannot allocate it. It's just a flag to indicate that it may be used in a logical volume managed way or manner. So now that that's in place, the next step is to use our LVM tools, as we've mentioned. So PV set of tools, PV create, PV display, there are a number of tools. For example, if you'd like to see the current configuration, PV display. This will show physical volumes that are currently defined and allocated to volume groups. So dev-SDA2 is the lone physical volume that LVM is aware of that is associated with a volume group called VG_LinuxCBT CentOS. And its size is 40 gigabytes roughly. Physical extents, 4 megabytes, total physical extents, and basically it's just segmentation of the volume, UUID, so on and so forth. So that means LVM does not recognize this new storage space, which is dev-SDC1, which means we need to PV create it. So E PV create dev-SDC1, and that will add this particular partition to the auspices of LVM. Now let's PV display again, and you'll see the new disk. Dev-SDC1 is now available and ready to be allocated. Now it's currently not allocated, so it's not allocatable, meaning it may not be allocated to a logical volume just yet until we first associate it with a volume group, which is why the steps we've pointed out are important. So you define a physical volume first, tie the physical volume into a volume group, and then it becomes allocatable. So the next step is to use our VG magical tools, such as VG create. As we've mentioned, the name of the volume group, so let's just take what we've already written. So that's going to be VG create volume group temp. Let's say we're going to create a new directory temp and mount it there, but it can be mounted anywhere. And this is going to be dev-SDC1 for now. We'll worry about dev-SDB3 at another point. We've yet to provision that partition. So let's go ahead and create this using dev-SDC1. So now, how do we know that the volume group exists? Let's say we've reset the screen buffer and we've forgotten the name. Certainly VG includes a set of tools, including VG display. So in addition to VG underscore hostname, short name, we have vol group temp, which is type LVM2 and is currently 9 gigabytes, can be extended at another point. So it's currently 9 gigabytes, the full capabilities of the partition that we just associated, which PV display reflects. Now notice that it's all of a sudden allocatable because it's a member of a volume group. So now that it's a member of a volume group, the next step for us in our process, as we've mentioned, is to export, let's say, a fraction of it to a logical volume. So let's LV create. Let's say of the 10 gigs, roughly 5 gigabytes, or maybe 8 gigabytes, with a name of maybe log vol temp 00 and a volume group of vol group temp. You have to specify the volume group because LVM needs to know from where the logical volume is to derive its storage. Now, before we LV create, let's LV display to see the logical volumes that exist. We don't see 02 show up when we do a DFH. Why? Because it's associated with swap. We see 00 and 1. So let's LV display again, piping the output to less. And we see 00, which is 20 gigabytes and associated with the root file system. 01, which is about 10 gigabytes and associated with the home file system. You won't see the references here, by the way. The references with respect to where they're mounted in the Linux file system are all spelled out in etcfs tab. That's the flexibility provided by management storage utilities like LVM that we can map the storage areas to anywhere we'd like. So there's really no need to specify within LVM where an item is to be mounted. That would be too restrictive. And then we see log vol 02 as our item. Now, insofar as our new item, LV create. And this will create a new logical volume. And then let's take a look using LV display less and alphabetically arranged. Instead of VG its vol group, and there we see that we've got 8 gigs ready to go, and this is the path. So dev vol group temp log vol temp 00. So now we're at the stage where we can actually overlay the file system. So let's go ahead and do that. Now let's take this command, because we'll like to make it ext4, and attempt to overlay as our almost final, so maybe penultimate step. Now let's try it out. There it's writing the node. Notice it takes the hyphen, it parses it, because it knows that the name of the logical volume is a subset of the volume group. So now we've laid out roughly 8 gigs ready to go, ext4. So the next step is simply to update etcfs tab. Now, what will we update it with? The idea is to use block ID, need not remember the name, obtain UUID, and update etcfs tab. And of course check that it mounts. So we'll probably create a directory naming it perhaps /temp as a temporary location. So let's block ID, and we should see this new entry, dev mapper vol group temp log vol temp 00. What's important is the UUID. LVM, so long as LVM is loaded when the system comes up, it'll know where these various IDs are, because the dev entries will be automatically created for us. But you could use the name dev mapper, the volume group name, and the logical volume name. Let's modify etcfs tab, and in our logical volume area, let's perhaps place it right above the default swap, and this will be LinuxCBT classroom. And this will be, let's say, /temp LVM volume, for example. There's a UUID /temp, which we've yet to create, ext4 defaults 1 and 2 in terms of the dump and the check. Now let's make directory /temp so that it's available. And the last step is simply mount A to make sure that it mounts. Now let's echo the exit status, and then let's dfh, and there we have our new storage, which is just about 8 gigabytes, and it's managed by LVM. It's intact, and because it's a fresh partition, it certainly has a lost and found directory it can be written to. You could flag it with various permissions such as setgid, setuid, sticky bit, so on and so forth. It's new storage, it's at 8 gigabytes, and it's now ready to be managed by LVM using its full arsenal of features, which includes, of course, reductions, extensions, so on and so forth. So we've started out at 8 gigs. The next section will extend, bring another storage block into the equation, and so on. So just to quickly recap, the various tools. PV display shows the physical volumes that are eligible to be members of volume groups, and each physical volume reflects the member volume group. So SDC1 belongs to this group, SDA2 belongs to that group. The next level up in the hierarchy, VG display, shows the various volume groups that are available on the system to be segmented into various logical volumes. Vol group temp and VG_LinuxCBT cent1, both are available, and both have storage to be segmented. And then LV display, the third of the 3 tiers, shows the individual logical volumes on which we overlay file systems such as ext4, as well as swap. Swap is a file system in and of itself, so logvol02, for example, is not overlaid with ext4, but rather swap. So now we have that in place. If we reboot the system, this will be made available. So the next step for us is to manage using LVM